This is the Leaving Cert Ordering Level DEBmock from 2020, Paper 2, Question 1. And we size it there. So this is a probability question using primarily the idea behind the fundamental principle of counting. So I'll work through it. It's looking at working out different combinations of or permutations for codes for a locker. So it clearly explains a 4-digit security code using the digits 0 to 9. It clearly states that it cannot begin with 0. Okay. Initially, for this question, it does say that numbers may be repeated. We'll revisit that stipulation later on in the question. So, firstly, just through common sense, write down the smallest possible code. Well, it's 4 digits. Okay, it cannot start with a 0. So the smallest, most significant digit is the first one, and the smallest it would be 1. Okay, if you think about it after that, if you can repeat digits, you could have 0, 0, 0. Okay, that would give you numerically the lowest number, the smallest number as such. Okay, everything else, okay, if you have 2s or 3s or 4s as the first significant digit, okay, or if you had any numbers in here other than zeros, they are effectively larger than this code that we've come up with. So then moving on to the second part, how many different codes are actually possible. So here we're wanting to work out how many different numbers other than 1000 are there. So realistically, we can go up as far as 9999. And you can sit here and decide yourself, okay, well, how many numbers are between, inclusive of up as far as 9999, but down as far as 1000. Well, I suppose you could just say to yourself, well, if there are 9999 codes, okay, of which the first 999, i.e. all the codes less than 1000, 1000, okay, if I take away those from all the possible codes, I'm left with just 9000. That's one quick way of getting your answer. Using the fundamental principle of counting as a concept, if you think about, you've got 4 different digits you have to actually fill to make your code. So how many options do you have for the first one? Well, you've got all the digits from 1 up to 9, 0 is not included. Okay, so you can't have 0 in there, so there are 9 possibilities. After that, okay, and don't forget we can repeat as much as we like. After that, how many digits have we got to choose from? We've got all the digits from 0 up to 9, so that's a choice of 10. Again, 10, 10. Now, we're able to do that every single time. We can repeat as much as we like, and that's our answer. And lo and behold, we get the same answer of 9000. So for part A, that was worth a total of 5 marks. Moving on to part 3. This part here had separately its own 5 marks available. So how many different codes do not contain a 0? So I suppose we have to say to ourselves, well, again, there's a code which has 4 digits. Okay, so how can we fill those 4 digits? We can't have a 0 in the first one. We also can't have 0 in the second, third, or fourth, because we're having no zeros whatsoever. Okay, we can repeat as much as we like. So the first one's got 9 possible digits, 1 to 9, and likewise the next one has 1 to 9, and the third one, and the fourth one. And 9 times 9 times 99 gives you 6561 for 5 marks. Moving on to part 4 for another 5 marks again. Now here it's actually asking for a probability. It's not just asking for how many different codes, it's asking for probability. So in this one, it's asking for all the codes that contain at least 1 0. Now if you think about this compared to the previous question, this was where it didn't contain any zeros at all, and this is where it contains at least one 0. And they're opposites to each other, they're mutually exclusive effectively. Okay, so what we could do is we know how many codes there are in total. There are 9,000. We know that 6,561 of them do not contain a 0. Therefore, the ones that do contain at least one 0 must be the difference between that. So if we take 9,000 and subtract 6,561, we get 2,439. You can do that on your calculator. So they're the number of codes that contain at least one 0. We're asked for probability. So it's all, probability is the amount that fits the criteria divided by the total possible. So in this instance, my probability is 2,439 divided by the total, which is 9,000. So that is just an answer. You can work it out as a decimal, and it comes to 0.271, which rounds to 2 decimal places to 0.27. Okay, if you wanted to, you could write it as a percentage format, which would be 27%. Realistically, I think the most appropriate thing to do is to give your answer as it asks, correct 2 decimal places. And that question was worth 5 marks. So if we move on to part B. So Liz has forgotten her security code. She knows she used 2 prime numbers when selecting the code. She also knows that no number was repeated in the code. So this is the difference. This is a slightly different question. There's no repetition. So once a digit was used, it wasn't used again. And she also states that she has 2 prime numbers. Okay. Finally, how many attempts would it take for Liz to open the locker if the 2 prime numbers were next to each other? Okay, so let's first of all deal with that. So the idea we're dealing with is her code was either a prime, then another prime, one after the other, and then 2 that weren't primes. We may have a situation where it started off with a non-prime, and then there were 2 primes in the middle, and then it finished off with a non-prime. Or last option would be it starts off with 2 non-primes and then finishes up with a pair of primes. So we can look at each of these 3 scenarios and decide what's going on with these. So the other thing we need to appreciate is what are the prime numbers. So they're testing your understanding of prime numbers. Prime numbers are 2, 3, 5, and 7. And the non-primes would be all the other values, which would be 0, and 1, and 4, 6, 8, and lastly 9. So there's 4 primes, there are 6 non-primes. So using the fundamental principle of counting, the idea is we work our way through left to right and assign the different scenarios, how many different choices can be made for each position. So for the first position, it's a prime number. We can pick any of those primes. There's 4 to choose from. And then for the second prime, well, once we've chosen one of those primes, there's one that's gone, so there's only 3 left. So for the second prime, we only have 3 to choose from. Then we have to go and deal with the non-primes. So there are 6 possibilities for that first non-prime, and for the last digit, the second non-prime, we've used up one of these 6, so we only have 5 left to choose from. That works out as 360. Let's look at the second scenario using the same process. Okay, now here we've got a non-prime as the first digit. Well, if you remember from the previous criteria, previous part, 0 couldn't be the first digit in the code. So we can't include 0 in for considering the first non-prime as the first code. So we only have 5 left over. So there's 5 to choose from for the first one. We then have for prime, we have 4 to choose from. And then for the second prime, we only have 3 left over to choose from. And then lastly, for the last non-prime, well, how many non-primes we have? We remember that we had 6 originally. We use 1 up, okay? And now here, 0 is an option, okay? So we have 5 left over. If you think of it, 6, we had 6. Okay, we weren't able to use 0 for the first option, so we use one of the others, but then we have the 4 remainder plus the 0 to choose from. It's 5 in total. Okay, that works out as 300. And lastly, this scenario, this arrangement here, where you got non-prime, non-prime, prime, prime, it's a very similar process. So we have 6 non-primes, but we can't use 0. So there's only 5 that we can choose from. And then for the second non-prime, we have 5 again because we can include 0 in our possibilities for that second non-prime. And then we have 4 primes to choose from, and then lastly 3 primes to choose from. And that is also 300. So if we add up those values, we have what, 360 plus 300 and 300, which gives me 960. Now I should point out to you here, I don't know whether you've looked at the official mark scheme for this paper. You will see on page 59 of the mark scheme that for some reason they're suggesting that that 960 should be doubled. Everything should be doubled. Okay, that is incorrect. Okay, this answer of 960 is the correct answer for 10 marks. And if for any reason you worked through this question, you got 960, but they marked you down because they were using an incorrect mark scheme, then, well, you should have got the full 10 marks.